In this video, we'll be looking at disproportionation reaction. Disproportionation reaction is a type of redox reaction in which a single substance is both oxidized and reduced, forming two different compounds. So you have one species undergoing a reduction and at the same time undergoing oxidation. So that reaction can occur within the halogens, and chlorine usually undergoes such reaction. So if you have chlorine plus an alkali, dilute alkali, you are going to have a disproportionation reaction. Now, one thing to take note of is that this reaction depends on the temperature. So let's see what exactly happens if we react chlorine with sodium hydroxide. You need to take note that this reaction is occurring around 15 degrees Celsius. That is in a cold condition. So what happened? You have chlorine aqueous plus 2 moles of sodium hydroxide, and you're going to have sodium chloride. You're also going to have sodium chlorate, and you are going to have water. So what makes this reaction to be a disproportionation reaction? Now we need to look at the oxidation state of chlorine. Now over here, chlorine has an oxidation state of 0, and over here it is -1. Now over here, the oxidation state of chlorine is +1. So you can work that out. ClO minus, if you work out the oxidation state of chlorine, you are going to get +1. Now, the fact that we are having chlorine moving from 0 to -1, that shows that it is a reduction process, and the same chlorine is having an oxidation state of +1 in the sodium chlorate. That is an oxidation. So we have two things if we are to write the ionic equation. Now for the reduction, we have chlorine. So let's say half mole of the chlorine gas gaining an electron and forming a chloride Cl minus. In that case, the oxidation state over here will be 0, and over here we have -1. Now at the oxidation half, we have chlorine again, Cl2, forming ClO. So in order to balance the chlorine, I'm going to put 1/2 over here, and now we have ClO. We need to balance oxygen. So what happens is we have 1 oxygen here. I'm going to add 2 moles of hydroxide to the left. Now remember, this is happening in an alkaline medium, so we have 1/2. Cl2 plus 2 moles of OH minus, and then we have ClO. And to balance the hydrogen, I'm going to add 1 mole of water. And then, so we have 1 mole of water here. The only thing left to balance here is the charge. All right, so we have 2 minus on the left and we have minus 1 on the right. So to balance this, I'm going to add plus 1 electron to balance the charge. Now what happens if this reaction is taking place at a higher temperature, around 70 degrees? Chlorine aqueous reacting with 6 moles of sodium hydroxide and this is going to give us 5 moles of sodium chloride. Then we have sodium chlorate. Now, how do you show the ionic equation involved in this? Now, remember that the sodium is a spectator ion, so we are not going to include sodium. Now, for the reduction, we look out for the change in oxidation states. Chlorine over here, it's 0, and over here, it is minus 1. Now, in the sodium chlorate, chlorine here is going to be plus 5. Just to show you how I work out for the 5, we have ClO3 minus. Remember that sodium is a spectator ion, so we're not going to include that, which means that I have X for chlorine and then 3 times minus 2, which is the oxidation state of oxygen, being equal to minus 1. Now, if you work out X from here, you get plus 5. So that is the oxidation state of chlorine in sodium chlorate. So from 0 to minus 1, that is reduction. So I have chlorine, Cl2, becoming Cl minus. So all I have to do is to add the electron over here to form the chloride. In order to balance the chlorine, I put 1 over 2 here to make it 1 chlorine. Now for the oxidation half, for the oxidation half, we have chlorine, Cl2, becoming ClO3 minus. Once again, we are ignoring the sodium. So if the sodium is no longer there, then we need to put a minus charge on the compound anion. We need to balance the oxygen. So I'm going to put Cl2. To balance oxygen on the left, I'm going to bring 6 moles of hydroxide. Remember, if you have 3 moles of oxygen, if you have 3 atoms of oxygen on the right, to balance it, you add times 2 of hydroxide on the left. So 6 moles of hydroxide giving me ClO3 minus. To balance hydrogen, I'm going to add 3 moles of water. 3 moles of water. All right. Now, chlorine on the right is 1 and on the left it is 2. So I'm going to multiply this chlorine by 1 out of 2 to balance it. So the last thing to balance is the charge. 6 times minus 1 is giving us a charge of minus 6 on the left. On the right, we have only minus 1. So to balance it, I'm going to have 1 over 2 Cl2 plus 6 moles of OH minus, and I have ClO3 minus plus 3H2O, and then I'm going to add 5 electrons to compensate the charge. So this is the balanced oxidation half. Remember, this is oxidation, and so we are going to have the electrons on the right, and for reduction, the electrons are supposed to be on the left. So if we combine these two equations, we are going to have the overall equation, which is the reaction we've seen over here. So that is disproportionation reaction. Chlorine is getting oxidized, at the same time it is getting reduced. Now, I know your question might be, what about the other halogens? Fluorine is the most electronegative element, so if I pick fluorine, it will be very difficult for chlorine to be oxidized. So fluorine cannot undergo a disproportionation reaction. Now, chlorine can undergo disproportionation as well as bromine. Just that bromine will not undergo the reaction easily compared to chlorine. Now, iodine can undergo the same thing, but the ease of the reaction, the feasibility decreases as you go down the group. So this is disproportionation reaction.